The discovery came quietly, as most profound revelations do, not with thunder, but with a faint speck of light. On the night of July 1st, 2025, atop the cold mountains of Chile, the Atlas telescope detected something unusual, a faint traveler moving against the tapestry of the constellation Lynx. Its path was unlike anything bound to the sun. Astronomers, trained to spot the predictable arcs of asteroids and comets, quickly realized this object was different. Its trajectory was hyperbolic, meaning it wasn't tied to our solar system at all. They named it 3I Atlas, humanity's third confirmed interstellar visitor after the enigmatic Oumuamua in 2017 and 2I/Borisov in 2019. The 3I designates its place in this brief but monumental lineage, each eye a reminder that these are interstellar wanderers, born in distant suns and exiled into the abyss. Unlike the familiar planets and comets that loop endlessly around our star, 3I Atlas cuts a straight escape path. Its orbital eccentricity is greater than 1, the unmistakable mathematical signature of an unbound traveler, racing inward from the dark between the stars. It carries with it chemical memories and cosmic scars from a birthplace our telescopes will never see. The numbers are staggering. At its fastest, 3I Atlas moves at more than 130,000 miles per hour, fast enough to cross the width of the United States in less than 3 minutes. At perihelion, its closest approach to the sun, it will swing inward with breathtaking velocity before flinging itself back into the void. And yet, despite this drama, there is reassurance in the data. Its closest approach to Earth will be nearly twice the distance between Mars and our world. By every calculation, Atlas poses no danger. NASA has been careful and consistent. This is a natural comet, not a spacecraft, not a threat. The orbit has been plotted, the risks assessed. By all accounts, we should rest easy. But human imagination rarely rests. For every equation that guarantees safety, there lingers another question. What exactly are we looking at? When astronomers remind us that this is a harmless wanderer, the word harmless does more than soothe. It also stirs the shadows, because what frightens us most is rarely the collision of rock and ice, but the collision of ideas. Could a visitor like this carry more than dust and frozen gases? Could it perhaps carry intention? Already the great observatories of the world have turned their gaze upon Atlas. The Hubble Space Telescope has captured its coma, a faint veil of light as solar radiation awakens its ices. The James Webb Space Telescope has pried into its chemical heart, revealing a richness in carbon dioxide unlike anything in familiar comets. To the instruments, it glows as comets do. To the equations, it moves as comets move. But behind the glass of control rooms, astronomers still whisper, "What if?" Because this is not just a body of rock and ice. It is a message in matter, a sample delivered from the deep galactic past. Every interstellar visitor is a chance to read history, billions of years old. If Oumuamua was a riddle, and Borisov a reassurance, Atlas feels like a test. The worst-case scenario is not a cinematic impact with Earth. That possibility is already gone, written out of reality by the clean geometry of orbital mechanics. No, the worst case is stranger. The worst case is that this visitor forces us to confront how little we understand of the universe's intentions. So the question lingers. When Atlas completes its loop round the sun and races outward again, will we have merely catalogued another comet? Or will we have glimpsed something more? An echo of distant intelligence, or a reminder that cosmic coincidences may not always be coincidences at all. For now, Atlas remains what it appears to be, a cometary messenger streaking across our skies, no closer to us than Mars, no more dangerous than the starlight above. But tonight, as we set the stage for its journey, we step into the quiet space between certainty and speculation, the shadows where science meets story, and where the universe sometimes speaks in riddles. Speed is a form of poetry in the cosmos, and 3I Atlas writes it in blazing lines across the dark. At over 130,000 miles per hour, it outruns every spacecraft humanity has ever built, every bullet ever fired. Its excess velocity, 61 kilometers per second, even after accounting for the sun's pull, tells us this: nothing will stop its journey. Not our star, not our planets. It is passing through, uncatchable, like a whisper of some older age. This speed is not random. Astronomers suspect it carries the echoes of a violent past, a slingshot escape from its birth system, perhaps, or a chain of gravitational encounters that gradually flung it into exile. Its two predecessors, Oumuamua and Borisov, were quick, but not this quick. Oumuamua traveled at 26 kilometers per second, Borisov at 32. Atlas moves nearly twice as fast. Why? Did it suffer a more chaotic ejection, or does this accelerating pattern hint at something more unsettling? A hidden pattern, a progression? If speed is staggering, then size is elusive. The coma, the glowing cloud of gas and dust surrounding Atlas, obscures its nucleus, the comet's true body. Estimates range from a mere 300 meters to as large as 5 kilometers, the difference between a small mountain and a city block of ice. Astronomers lean toward the smaller end of the scale, but the truth hides beneath that luminous shroud. And here lies another puzzle. How could something so small survive so long? The journey between stars is merciless. Radiation tears at molecular bonds, collisions with dust grains erode surfaces, tidal forces threaten to tear fragile bodies apart. Statistically, small wanderers should not endure, yet here it is, intact, ancient, and impossibly fast. This leads us to its most mysterious quality: age. Atlas may be older than the sun itself. Its trajectory suggests origins in the thick disk of the Milky Way, an ancient stellar population that formed when our galaxy was still young and turbulent. While the thin disk, the region where our solar system resides, spins with relative order, the thick disk stars trace more chaotic orbits, tilted, eccentric, unaligned. Atlas approaches from such an angle, as though it carries the momentum of that ancient chaos. If true, this comet is a relic from more than 10 billion years ago, when the Milky Way's structure was still being forged. Imagine it. Before Earth had oceans, before the sun had ignited, before life had ever sparked, Atlas was already wandering. Every revolution of stars around the galactic core, Atlas drifted. It passed the birth of countless suns, skirted regions where planets formed and civilizations may have risen and fallen. It has been a silent witness to epochs longer than anything our species can imagine. And so the question presses: what does survival across such time mean? For astronomers, it speaks of endurance, natural resilience of icy rock in the void. But for the speculative mind, endurance sometimes whispers of purpose. Could an object survive so long because it was meant to? Because it was built, not merely born? The leap is daring, perhaps reckless, but so is human imagination when faced with ancient mysteries. There is also the strange coincidence of timing. Atlas arrives now in an age when humanity has telescopes powerful enough to study it, computers fast enough to simulate it, and imaginations bold enough to speculate. For billions of years, it wandered unseen. For billions more, it may continue unobserved. But here, in this brief window of a few months in 2025, it passes through our skies, and we are watching. Coincidence? Almost certainly. Yet the unsettling thought remains. If it were deliberate, would it look any different? Despite the riddles, astronomy grounds us in clarity. Atlas will not stay. Its speed forbids capture. Its trajectory guarantees departure. But it has already given us something profound: a mirror. By studying its speed, its uncertain size, its impossible age, we glimpse the scales of time and endurance beyond ourselves, whether natural fragment or just possibly something more. 3I, Atlas is a cosmic survivor, and in its survival, it forces us to ask, What endures and why? When sunlight awakens a comet, its secrets spill into space. The heat turns ice into vapor, vapor into a shining veil, the coma, that cloaks the nucleus in mystery. For most comets, this unveiling is predictable. Water dominates, with carbon monoxide and carbon dioxide appearing in smaller rolls. But when the James Webb Space Telescope trained its instruments on 3000 Atlas in August 2025, the script broke. The data revealed a shock. Atlas's coma was dominated by carbon dioxide, with a CO2 to water ratio of nearly 8 to 1. Not unusual, not rare, unprecedented. Comets in our solar system never display such chemistry. To astronomers, it was as though this object spoke in an entirely different dialect of the molecular language. Natural explanations exist, of course. Perhaps Atlas formed near the CO2 snow line in its home star system, a colder region where carbon dioxide freezes out of the protoplanetary disk before water does. Or perhaps its surface chemistry was altered over billions of years by cosmic rays, building a radiation-hardened crust that traps water but allows CO2 to escape. Another idea suggests a dust mantle, an insulating blanket that buries water ice deep below, while lighter, more volatile carbon dioxide seeps upward. But explanations do not erase the strangeness. To find an object so far from home, so ancient, and discover that its very breath, the gases it exhales into the void, is unlike anything we know. This feels less like coincidence and more like encounter, and here is where speculation begins its quiet invasion. Some ask, could such an extreme chemical ratio be a marker, not an accident? Could it be the equivalent of a cosmic flag, designed to stand out in the spectral lines astronomers so carefully measure? After all, we humans already dream of sending chemical beacons into space, messages encoded in isotopes or engineered molecules that no natural process could replicate. If we, a young civilization barely 2 centuries into industry, imagine such things, what might an older intelligence achieve? Consider, too, the timing of the detection. When Webb observed Atlas, the comet was still more than 3 astronomical units from the Sun, well beyond Mars. At such a distance, comets are usually quiet, their water ices locked in deep freeze. And yet, Atlas was active, exhaling carbon dioxide in visible plumes. It seemed eager to announce itself, glowing when others would still be dark. Coincidence? Almost certainly, but unsettling nevertheless. Astronomers are careful not to leap beyond data. They remind us that comets are chemical time capsules, each bearing the fingerprint of its birthplace. In that sense, Atlas is not an anomaly, but a gift, a sample of alien geology, a frozen record of conditions round a star we may never even identify. By studying its chemistry, we expand our models of planetary formation, broadening the spectrum of what worlds, and by extension, what life might be. Yet the human imagination, restless as ever, wonders, what if chemistry can be more than record? What if it can be code? The way ink on parchment is more than pigment. The way DNA is more than molecules. What if the ratios we observe are not just byproducts, but signals? This speculation gains fuel from precedent. In 2016, Comet C/2016 R2, pan-stars, also startled astronomers with strange volatile abundances, rich in carbon monoxide and nitrogen, far outside the norm. Alone, such anomalies might be dismissed, but taken together, they hint at a galaxy more chemically diverse and perhaps more communicative than we dared expect. The power of Webb's instruments lies in their precision. Molecules sing in light, each vibration and rotation leaving a spectral fingerprint. The telescope hears those songs across the infrared, decoding the invisible. When it listened to Atlas, it heard not the familiar chorus of water, but a voice dominated by carbon dioxide, a voice that for the first time seemed almost alien. As Atlas draws nearer to the Sun, its chemistry will evolve. If deeper layers of water ice awaken, the ratios may shift, or they may not. And if they do not, if Atlas continues to breathe CO2 in defiance of amounts of every expectation, then the questions will grow louder. For now, astronomers catalog, compare, debate. But beyond the safety of consensus, the darker curiosity persists. What if the chemistry of 3I Atlas is not just the fingerprint of a star system long vanished, but a message etched in ice? A message we have only just begun to read. Numbers, in their precision, can feel like comfort, and the numbers for 3. I Atlas tell a clear story. There is no threat. The comet will pass no closer than 1.8 astronomical units, about 270 million kilometers, from Earth. That's nearly twice the closest distance between Earth and Mars, and more than 50 times farther than our moon. To the laws of celestial mechanics, Atlas is nothing more than a harmless passerby. Orbital calculations, refined through centuries of astronomy, leave little room for error. The trajectory has been mapped with exquisite detail, accounting for planetary poles, solar radiation, even the delicate nudge of outgassing jets. The verdict? Atlas will not strike, will not even come near enough to cause disruption. It is simply passing through, and yet, reassurance is rarely the end of the story, because while the mathematics protects us from collision, it cannot protect us from mystery. What unsettles is not what Atlas will do, but what it might mean. If Oumuamua taught us anything, it is that the universe occasionally hands us puzzles that numbers alone cannot solve. Atlas, with its impossible speed and alien chemistry, may be another such gift, or another such test. There is irony here. The very velocity that makes Atlas dramatic also makes it safe. At over 130,000 miles per hour, it is moving too fast to be captured by the sun's gravity. Unlike comets bound to looping orbits, Atlas cannot linger. It will dive past the sun and vanish into interstellar darkness once more, never to return. That speed is our shield, a guarantee that this is a brief encounter, not a lasting presence. NASA's official statements reflect this clarity. In their careful, measured language, they stress both the wonder and the harmlessness. They remind the public that this is a natural object, remarkable but not dangerous. Their tone is calm, almost parental. Fascination is welcome, fear is not, and yet for some, the very calmness sparks suspicion. Because when the unknown brushes against our world, reassurance can sound like denial. The media walks its own tightrope. Some headlines emphasize the cosmic drama. An interstellar visitor approaches. Others lean into reassurance. No danger from alien comet. But woven between these poles is the echo of a deeper question. Is danger only measured in impact risk? What about the danger of revelation? For even if Atlas is nothing more than a comet, it forces us to confront our place in a universe teeming with such wanderers. It reminds us that the galaxy is alive with motion, with fragments of other worlds constantly passing near our own. And it whispers that we are not the center, but merely one-way station in a larger, older journey. What if the worst-case scenario is not destruction, but discovery? Not collision, but contact. Atlas's approach offers no Hollywood catastrophe, no apocalyptic impact. Instead, it offers something subtler and perhaps more unsettling, a confrontation with the limits of our understanding. If its chemistry continues to defy expectations, if its path or activity shows even the faintest hint of intention, the implications would ripple far beyond astronomy. For now, the evidence aligns neatly with the natural explanation. The coma glows, the trajectory arcs, the chemistry puzzles, but does not yet break the rules. By every observable measure, Atlas behaves as a comet should, and yet, just beyond the reach of certainty, the speculative shadows lengthen. Perhaps that is the true gift of 3I Atlas, not the reassurance of its harmless passage, nor the mathematics that guarantees our safety, but the lingering questions that numbers cannot silence. Now we step across the thin line where certainty ends and speculation begins. By all evidence, 3I Atlas is a comet, an icy wanderer expelled from some long-forgotten star system. It behaves like one, it shines like one, it exhales gas like one. The safest explanation is the simplest: nature, not design. And yet, in history, the simplest explanation has not always been the final truth. Consider pulsars. When first discovered in 1967, their radio signals were so regular that they were briefly labeled LGM1 for little green men. Of course, they turned out to be rapidly spinning neutron stars. No aliens, just physics, stranger than we had imagined. Or the fast radio bursts that puzzled astronomers for years, some speculating about cosmic beacons until their origins in extreme astrophysical processes began to emerge. Nature, it seems, can mimic intent with unnerving precision. But what if, in rare cases, intent hides within the natural? Harvard astrophysicist Avi Loeb stirred controversy when he suggested that Oumuamua might have been artificial, a probe, perhaps, pushed by light like a solar sail. Most of the astronomical community dismissed the idea as unlikely, preferring natural explanations. Yet Loeb's point lingers. If we never allow ourselves to ask the artificial question, we may never recognize the answer. So what would it take for Atlas to cross that line? What evidence could force us to abandon the comet hypothesis and consider something more unsettling? Astronomers outline the signs: radio emissions that carry structure, repeating patterns, or narrow band frequencies too precise for nature, non-gravitational accelerations that do not match patterns of outgassing, movements suggesting guidance, not randomness, light variations that hint at controlled orientation rather than chaotic tumbling, as though the object were deliberately adjusting its face to the sun. So far, Atlas has shown none of these. Its radio silence is complete. Its trajectory matches the expected curve of a comet, down to the tiny nudges from sublimating gas. Its brightness changes, follow the rhythms of rotation and solar heating, nothing more. Every dataset speaks of nature, and yet, absence of evidence is not evidence of absence. Oumuamua taught us this lesson too. Its unusual shape, its faint push away from the sun, were these quirks of natural comet physics, or something else? In the end, the balance tilted toward nature. But the debate revealed a deeper truth. Our instruments are only just now sensitive enough to ask these questions. We are like children standing at the edge of an ocean, debating whether the ripples in the surf are random or purposeful, while the deep sea remains unseen. Speculation, when done responsibly, is not folly. It sharpens the questions. If we imagine Atlas as a craft, we are forced to ask what distinguishes a comet from a probe. What tests would reveal design where none is obvious? These thought experiments become frameworks for future discoveries. Imagine, for example, if Atlas were to shift course slightly as it passed the sun, just enough to suggest propulsion, not outgassing. Or if its chemical signature shifted in ways no thermal model could explain, such evidence would be undeniable. But until then, the hypothesis remains a ghost, intriguing but insubstantial. Still, history reminds us to remain open. Some of the greatest discoveries have come from refusing to dismiss the improbable. Quasars, once thought impossible, turned out to be the blazing hearts of galaxies. Black holes, long considered mathematical curiosities, are now photographed. The extraordinary has a way of becoming ordinary once evidence forces us to see it. For now, Atlas is what it seems: a comet, carrying alien chemistry but natural in origin. And yet, in the quiet of observatories and the imaginations of those who watch, another possibility whispers. What if we are wrong? What if this is not simply a wanderer, but a messenger? What if beneath the coma of dust and ice lies something crafted, waiting, silent? We stand at the threshold of speculation, peering into the shadows where comets and crafts blur, and it is here in the uncertainty that the most haunting possibilities begin. Imagine for a moment that 3I Atlas is not what it appears to be, that the glow of its coma, The jets of carbon dioxide, even the elegant arc of its orbit, all of it is camouflage. To us, it is a comet, but to another intelligence, it could be something more. A probe, wrapped in ice, cloaked in natural behavior, passing through our solar system unnoticed. This thought draws us into the dark forest hypothesis, a haunting idea borrowed from science fiction but taken seriously by some philosophers of SETI. The hypothesis imagines the galaxy as a vast forest. Each civilization is a hunter, moving silently among the trees. To reveal oneself, to send out signals, to advertise existence, is to invite danger from others who may not respond with friendship, but with annihilation. In such a forest, survival demands silence, observation, not communication. If the dark forest is real, then 3I Atlas becomes more than a comet. It becomes the perfect scout. What better disguise than a comet? One of the most common and least suspicious wanderers in the galaxy. Its coma explains its outgassing. Its brightness explains its variations. Its silence explains its lack of signals. Nothing about it seems artificial. Precisely the point. The engineering challenge of such a probe would be staggering. It would need to mimic cometary behavior flawlessly, correct chemistry, appropriate sublimation, a nucleus rough enough to scatter light naturally. Inside, it might carry instruments, sensors recording electromagnetic emissions, cameras peering at planets, perhaps even a system to relay information back across interstellar gulfs. Its power source would have to endure billions of years. Nuclear decay, fusion microreactors, or technologies we cannot even imagine. And perhaps its most chilling feature? Patience. Human missions last decades. This mission, if it exists, has lasted billions of years. Its builders may be gone, their civilization extinct, and yet the probe continues, obeying instructions older than our species. If such a device were real, what would it seek? Perhaps it would measure our technology, the faint radio bubble expanding from Earth since Marconi's first transmissions. Perhaps it would catalog planetary atmospheres, sniffing for oxygen, methane, or industrial pollutants. Perhaps it would simply wait. Its true systems dormant, programmed to awaken when conditions were right. Speculation pushes us further still. What if Atlas is not alone? What if other comets, drifting through our solar system in ages past, carried similar secrets? The cometary clouds could be full of watchers, silent, hidden, indistinguishable from ice and rock. In this vision, the universe is not empty. It is crowded with eyes. We just cannot tell which eyes are watching. The implications for humanity are profound. If Atlas were truly a disguised probe, our response would matter more than its presence. Do we announce ourselves? Do we attempt to communicate? Or do we follow the dark forest rule and remain silent, hoping that observation does not become judgment? History shows us that first encounters between civilizations on Earth rarely ended with equality or peace. Why should the cosmos be any different? For now, of course, this remains imagination. Every observation of Atlas fits the cometary model. Its coma, its chemistry, its orbit, all are explicable without invoking technology. And yet, the hypothesis lingers because it asks a question that science cannot dismiss so easily. If an advanced intelligence wanted to watch us without being seen, what better mask could it wear than this? Atlas glides through our skies, serene, indifferent, ancient. To science, it is a comet. To speculation, it is a shadowed possibility, a reminder that in the dark forest of the galaxy, silence may not mean absence. It may mean we are not alone, and that we are already being watched. If we allow ourselves to imagine 3I Atlas as more than comet, the question sharpens into something even more haunting. Who made it? And perhaps more importantly, what became of them? This is where the idea of the Great Filter emerges, one of the most unsettling concepts in the search for extraterrestrial life. It proposes that somewhere along the long path from chemistry to intelligence to interstellar civilization lies a nearly impassable barrier. Life may begin, even flourish, but very few make it past a certain step. Most fail. Most vanish. If Atlas is artificial, its very age confronts us with chilling possibilities. Astronomers suspect it may have been wandering for billions of years, a relic from the thick disk of the Milky Way. Imagine, then, a civilization advanced enough to build probes that could endure across galactic time. They would have mastered energy, materials, propulsion, problems that still confound us. They could reach across stars as casually as we cross oceans. And yet, where are they now? Perhaps they encountered their own great filter. Perhaps they fell to internal collapse, plagues of war, ecological ruin, the simple entropy of ambition outpacing wisdom. Perhaps they were erased by others, more ruthless hunters in the dark forest of the galaxy. Or perhaps they transcended into forms we cannot comprehend, leaving behind only their machines as the last traces of their existence. If Atlas is such a machine, then it is not merely a visitor. It is a ghost ship, a technological fragment adrift in interstellar seas, carrying the memory of a people who no longer exist. Its mission continues, not because anyone awaits the data, but because its programming knows nothing else. A civilization's echo still moving through the dark long after the voices that gave it purpose have gone silent. For us, this thought is more than speculation. It is a warning. Humanity is still young, still stumbling through its technological adolescence. Nuclear weapons, artificial intelligence, climate disruption, each is a test we are only beginning to understand. The great filter may lie ahead, not behind us. If so, then Atlas becomes not only a relic, but a mirror, a glimpse of what it means to succeed technologically, yet fail existentially. And yet, there is another possibility, one more hopeful. The great filter might lie in the early stages of life itself. If that is true, then the rise of intelligent beings like us is already vanishingly rare. Atlas, then, would not be the grave marker of a dead civilization, but the accidental emissary of one of the very few that ever made it so far. In that case, its presence would not just be eerie, it would be miraculous. Whichever interpretation we choose, the implications converge on a single truth. We are fragile. The universe is old. Civilizations may flare like sparks, brilliant for a moment, and then gone, leaving behind only drifting machines or chemical traces in ancient ice. To encounter such a relic, even disguised as a comet, would be to confront not aliens as they are, but aliens as they were, long vanished, their memory carried by the cold persistence of technology. So as Atlas races through our system, we are forced to ask, are we witnessing nature's handiwork, or the ghost of a civilization lost to time? And if it is the latter, will our own story end the same way, reduced to silence, leaving behind only fragments to drift, mute through the dark? In 1950, during a casual lunch conversation at Los Alamos, physicist Enrico Fermi posed a question so simple it still echoes like thunder across the decades. Where is everybody? The galaxy is ancient. The stars are countless. If life is common, if civilizations rise again and again, then the night sky should be alive with signals, structures, unmistakable signs of intelligence. And yet, silence. That silence surrounds 3i Atlas as well. Radio telescopes have listened carefully, scanning for the narrow band emissions that no natural process could produce. They found nothing, no beacon, no message, only the quiet hiss of sublimating gas and dust-scattering sunlight. By every measure, Atlas is mute. This absence should reassure us. It fits the comet hypothesis neatly, and yet, silence is not neutral. Silence can be strategy. In the framework of the Fermi paradox, there are many possible explanations for the void. Perhaps civilizations are rare. Perhaps they are short-lived. Or perhaps here the dark forest again overlaps. Perhaps they choose to remain invisible. If so, then objects like Atlas may play a role in that invisibility. Imagine a civilization that decides never to broadcast its existence openly. Instead, it seeds the galaxy with watchers disguised as natural debris, comets, asteroids, fragments indistinguishable from the cosmic background. These silent emissaries would drift unnoticed, blending in yet always observing. In such a scenario, detection is impossible, not because intelligence is absent, but because intelligence has chosen to hide behind masks of stone and ice. The unsettling truth is that our own civilization is already loud by cosmic standards. Since the early 20th century, our radio bubble has expanded over 100 light years into space, carrying television broadcasts, radar pulses, and digital chatter. If there are watchers, they already know we are here. Perhaps Atlas's arrival at this exact moment is coincidence. But coincidence, as history shows, is sometimes the cloak of design. Yet another explanation lies not in cunning, but in probability. Astronomers predict that trillions of interstellar fragments wander the galaxy. To us, Atlas is rare, but only because our telescopes have just now become sharp enough to find them. The silence may mean nothing more than statistics. We have seen too few to expect a signal. The Vera Rubin Observatory, soon to begin its all-sky survey, may change that, detecting interstellar visitors not once per decade, but several times per year. If all prove natural, the silence will grow louder, more profound. Still, the psychological weight of the silence cannot be denied. Humanity is a species that fears being alone, but also fears being found. We yearn for neighbors among the stars, yet recoil at the thought of contact. Three-Eye Atlas, in its silence, embodies that contradiction. It is the perfect symbol of the paradox. An emissary from another star, and yet mute, empty, indifferent. The silence whispers lessons if we listen carefully. It reminds us that intelligence may not reveal itself in the ways we expect. It may not beam radio waves across light years. It may not build megastructures that glow in infrared. It may hide, watch, wait, or it may be gone, leaving behind only relics disguised as natural wanderers. And so, as Atlas streaks past, it leaves us with Fermi's question sharpened, not answered. Where is everybody? Are they hidden behind comets like this one? Are they long gone, leaving only ghosts in the void? Or are we unbearably the only ones to ask? Now we enter the most speculative, almost cinematic territory. What if Three-Eye Atlas is not a probe, nor even a disguised sentinel, but something more insidious, something carrying the potential to transform worlds without warning? The idea has roots in science itself. For decades, scientists have debated the panspermia hypothesis, the notion that life may travel between stars on comets and asteroids, dormant until it finds a hospitable world. On Earth, we have found microorganisms capable of withstanding radiation, freezing, and even the vacuum of space. Could interstellar wanderers, like Atlas, be more than frozen chemistry? Could they be carriers of life itself? Now stretch that idea beyond biology to technology. Imagine microseeds, nanoscopic machines engineered by an ancient intelligence. Hidden in Atlas's icy nucleus, they slumber for eons. Radiation, collisions, the cold of interstellar void, none destroy them. They endure patient until the right conditions awaken them. Not a collision with Earth, not even a close pass, but something subtler, the rising hum of radio waves from a nearby planet, the spectral signature of industrial pollution, the electromagnetic flicker of cities, a signal not of biology, but of technology. In this speculative nightmare, Atlas becomes not a visitor, but a delivery system. As it sheds gas and dust near the sun, trillions of microscopic seeds scatter across space. Some fall into planetary atmospheres, some land on barren moons, a few perhaps drift toward Earth. What they do next is anyone's guess. Replicate, observe, infiltrate, or simply wait until humanity reaches a stage they deem significant. The idea is terrifying precisely because it feels invisible. An asteroid impact announces itself, but seeds of invasion would arrive quietly, hidden within dust, indistinguishable from natural particles. We would not know until it was too late. Of course, harsh reality strikes back against this speculation. Space is brutally unforgiving. Radiation tears apart molecules over millions of years. The violence of cometary outgassing would scatter or destroy delicate structures. And Atlas is not coming close enough for direct delivery. Its closest pass is nearly twice the Earth-Mars distance. Even the most imaginative scenario strains under the weight of physics. But imagination resists surrender, for history shows that humans often translate cosmic mysteries into metaphors for our own fears. In Atlas, we project the dread of hidden threats, pandemics, unseen technologies, infiltration rather than invasion. The silent spread of microseeds mirrors the anxieties of our age, when danger often arrives invisibly through data, viruses, or ideas. Perhaps that is the real power of this speculative scenario. Not that Atlas is literally a seed ship, but that it forces us to ask what kind of risks we are prepared to confront in a universe that may hold surprises beyond calculation. For all its implausibility, the seed of invasion thought experiment makes us sharpen our questions. How do we distinguish the natural from the engineered? How do we defend against what we cannot see? How do we respond to the unknown without surrendering to fear? Atlas, in reality, is almost certainly a comet, a wanderer exhaling carbon dioxide into space. But in our imagination, it becomes something more, a carrier of possibility, a mirror of our own anxieties, and a reminder that the line between science and story is often crossed not by data, but by fear. When Atlas was first spotted, it did not belong to any one nation or observatory. Within hours, its discovery flashed across international networks. Astronomers in Hawaii, Spain, Chile, and South Africa all pivoted their telescopes to follow its faint light. For once, the fragmented world spoke with a single voice. Look! The Minor Planet Center began collecting positional data, refining the orbit with each observation. NASA's Planetary Defense Coordination Office quickly ran the calculations, confirming what would become the first official statement: no threat to Earth. Soon after, the Hubble Space Telescope received emergency priority, interrupting other research to photograph the visitor. The James Webb Space Telescope, too precious to waste a moment, followed with spectroscopy, teasing apart Atlas's unusual chemistry. On the ground, radio telescopes listened, while amateurs in their backyards tracked the glow through CCD cameras. It was, in every sense, a global effort. This choreography revealed something about us. For all our political divisions, humanity still knows how to collaborate when faced with the unknown. The protocols of astronomy, open data, rapid sharing, transparent reporting, stood in sharp contrast to the secrecy that might have accompanied a military discovery. The sky belongs to everyone, and Atlas reminded us of that. But then comes the thought experiment. What if Atlas were not so innocent? What if one of those early radio scans had detected a structured signal pulsing across the spectrum? What if Webb's instruments had revealed chemical compounds impossible to explain naturally? What if Atlas, against all expectations, had slowed or changed course? Our systems for cooperation would have been tested to their limits. Who would speak for Earth? The United Nations? NASA? A coalition of spacefaring nations? Or would governments, fearing panic or advantage, shroud the discovery in secrecy? History offers little comfort here. Moments of discovery are often moments of division. The SETI Institute has long debated protocols for first contact, transparency, independent confirmation, rapid global communication. In theory, the plan is clear. In practice, the weight of geopolitics could smother it. An alien signal is not just science, it is power. Information becomes currency, and currency breeds competition. And then there is the public. News of Atlas has already spread across headlines and social media, framed in both sober analysis and fevered speculation. If real evidence of artificiality emerged, the information storm would be uncontrollable. Panic, hope, denial, conspiracy, the full spectrum of human reaction would ignite at once. Managing that firestorm might prove harder than managing Atlas itself. Yet, the reality is gentler and perhaps more beautiful. Humanity's first response to Atlas has not been fear, but curiosity. Scientists share images freely, publish data openly, invite amateurs to join in. The story of this interstellar visitor is unfolding in real time, written not by governments, but by a community of seekers spread across the globe. Even if the object were to harbor secrets, the way we responded in these first weeks would matter, because how we approach the unknown is a reflection of who we are. Do we meet mystery with silence and suspicion, or with wonder and collaboration? So far, Atlas has drawn out the latter, and that may be its greatest gift, regardless of what it ultimately proves to be. The arrival of 3I Atlas has forced us to confront a timeless tension. When faced with the unknown, do we seek to study it or to shield ourselves from it? History is filled with this conflict. Explorers crossed oceans despite storms and hostile shores. Scientists opened dangerous vials to study diseases, risking infection for understanding. Curiosity has always pulled us forward, while caution whispered, perhaps it's better not to look too closely. With Atlas, the question of containment seems almost irrelevant. Its closest approach, 270 million kilometers, makes any physical interaction impossible. No dust or ice will rain upon Earth. No fragment can reach us. And yet, the debate surfaces anyway, because what we fear is not just contamination of our soil, but contamination of our certainty. Planetary protection protocols exist for missions to Mars or Europa. Strict sterilization of spacecraft, careful planning for sample returns. But Atlas is not a mission we can control. It is a visitor. Its chemistry, its gases, its trajectory, none can be contained. Instead, what can be contained is information. And that, perhaps, is the more dangerous thought. What if future observations of Atlas revealed something inexplicable? Radio pulses, structured signals, anomalous motion? Would governments rush to classify the data, citing national security? Would scientists resist, insisting that knowledge belongs to all humanity? The battle between curiosity and containment would ignite not in laboratories, but in information networks. We already see hints of this tension. Social media, hungry for drama, thrives on speculation, rumors of alien ships, conspiracies of government cover-ups. At the same time, scientific institutions publish open archives, releasing Hubble and Webb images freely, inviting citizen scientists to analyze them. The two forces clash: transparency versus distortion, knowledge versus noise. There is a deeper irony. Containment, by its nature, breeds suspicion. If authorities withheld data, the absence itself would become fuel for conspiracy. Silence would be interpreted as confirmation. Curiosity, on the other hand, thrives on openness. By showing the data, by inviting scrutiny, science keeps fear in check. And yet, we cannot dismiss the possibility that someday the balance may shift. Imagine a future object, stranger than Atlas, unexplainable even under the broad tent of natural physics. Imagine if signals did emerge, if activity defied all known laws. Would humanity still cling to curiosity, or would containment prevail, smothering truth under secrecy? For now, Atlas leans the balance toward curiosity. Its distance ensures safety. Its chemistry, though unusual, remains natural enough to calm fears. The scientific community has chosen transparency, and the world watches together. But the larger question endures, hovering in the background like Atlas itself. When the universe finally presents us with something undeniable, something that challenges not just our science but our civilization, will we have the courage to remain curious? Or will fear lock the door, leaving us blind in the very moment we are most in need of sight. To speak of three eye atlas is to speak of distances and ages that stretch the human mind to breaking. Even its speed, over 130,000 miles per hour, is nothing against the scale of the galaxy. At that pace, it would take more than 10,000 years just to reach the nearest star. And Atlas has likely been moving not for millennia, but for billions of years. Its suspected birthplace, the thick disk of the Milky Way, carries the memory of a younger, wilder galaxy. 10 to 12 billion years ago, while Earth was still a swirl of dust and gas, the thick disk stars were forming in violent bursts, their orbits tilted and irregular, like scars from an ancient war. If Atlas comes from that era, then it predates not only our world, but the very conditions that made life here possible. Imagine what it has witnessed on its silent odyssey. Stars born and dying in supernovae, scattering heavy elements into space, entire planetary systems forming and dissolving. Perhaps even the rise and fall of civilizations that flared into existence and were gone again before Earth had continents. To Atlas, our history, the rise of agriculture, the building of cities, the splitting of atoms, would be less than a breath. These scales dwarf our presence. Humanity's electromagnetic bubble, our announcement to the cosmos, extends barely 120 light years, a fragile sphere of radio noise surrounded by silence. Within that bubble are perhaps a few thousand stars. Beyond it, hundreds of billions, utterly untouched by our presence. If Atlas carries instruments, or if watchers anywhere else exist, they would see us not as a galactic force, but as a newborn civilization still fumbling with fire. This perspective unsettles and reassures at once. On one hand, the galaxy is so vast that our fears of imminent invasion seem almost absurd. On the other, its silence becomes heavier. If so many stars and worlds exist, why do we see no obvious signs of intelligence? Each interstellar object we study becomes another data point in that silence. Oumuamua, natural. Borisov, natural. Atlas, likely natural. The pattern repeats, whispering the same absence. But absence, too, is information. It tells us that intelligence is either rare or cautious or fleeting. It forces us to consider that our expectations, beacons blazing across the stars, alien megastructures glowing in infrared, may be naive. Advanced civilizations may not want to be seen, or perhaps they no longer exist to be seen at all. Atlas, in its very strangeness, is a bridge across these scales. Its chemistry, alien to our system, proves that other stellar nurseries leave their mark on the galaxy. Its velocity demonstrates the sheer violence of planetary formation, the scattering of countless icy bodies into interstellar exile. It is not just a comet, it is a sample of galactic history delivered free of charge to our doorstep, and in its passing it reminds us of something humbling, that our place in the cosmos is not central, not even significant, except to ourselves. We are one story among billions, a brief flicker in a galaxy that has been writing epics since long before our sun was born. Atlas forces us to look up and reckon with the immensity of time and space. It does not threaten us with collision. Instead, it threatens us with perspective, an encounter not with danger, but with insignificance. And perhaps that is the greater challenge, to find meaning not in being the center of the story, but in being part of the vast, ongoing chorus of the universe. For all the unease that three-eye Atlas stirs, there is another, gentler truth. Its arrival has not only raised questions, but has also awakened wonder. The object is silent, yes, but silence does not mean emptiness. Silence can also mean listening. Across the world, telescopes great and small have turned toward this faint messenger, from the monumental mirrors of the James Webb Space Telescope to backyard instruments operated by amateurs. Data flows freely. Images, spectra, orbital refinements, most of it is shared openly, almost in real time. Humanity, fragmented in so many domains, still finds unity under the sky. Atlas belongs to no nation, no corporation, no army. It belongs to the shared heritage of curiosity. This openness matters. Knowledge, when shared, becomes a shield against fear. If information about Atlas were hoarded, suspicion would metastasize into conspiracy. But because scientists release data, because journalists explain trajectories, because teachers and enthusiasts bring images into classrooms, the narrative remains one of exploration rather than paranoia. There is hope, too, in the recognition that even in silence, discovery can inspire. Oumuamua provoked debates about technology and alien contact. Borisov confirmed that comets from other stars are not fantasy, but reality. Now Atlas, with its strange chemistry, pushes the frontier even further. None of these objects spoke, none carried messages, and yet each changed us. Each widened the horizon of what we know and what we dare to imagine. In this way, silence becomes a gift. If Atlas carried a signal, a message of undeniable origin, it might divide us, fueling fear, conspiracy, even conflict over how to respond. Instead, it challenges us with ambiguity. It asks us to collaborate, to pool our instruments, to compare theories, to embrace uncertainty together. The mystery does not fracture us, it binds us. There is also hope in the scale of the future. The Vera Rubin Observatory, soon to begin its vast survey of the sky, is expected to detect many more interstellar visitors. Atlas will not be the last. Perhaps some will be larger, brighter, closer, easier to study in detail. Each will expand our catalog of cosmic wanderers. Each will sharpen the contrast between nature and the faint possibility of design. The silence will not end, but the chorus of questions will grow richer. And even if none of them prove artificial, even if every interstellar traveler is merely ice and rock, the act of searching, of watching together, changes us. It reminds us that humanity's greatest strength is not weapons or wealth, but wonder. We are at our best not when we conquer, but when we observe, share, and imagine. So while Atlas streaks away, leaving us with more questions than answers, it leaves behind something enduring. A reminder that the unknown is not only a source of fear, it is also a wellspring of hope. Silence does not have to be emptiness. Sometimes, silence is the universe's way of inviting us to listen, to each other and to the stars. Every encounter with an interstellar object is also an encounter with ourselves. We look at Atlas through telescopes, but what we see reflected back is often our own imagination, our hopes, our fears, our longing for meaning in the silence. Is Atlas merely a story we tell ourselves? A blank page upon which we project the myths of our era? For centuries, comets have served as cosmic canvases. To ancient eyes, they were omens of disaster, heralds of war, divine messengers scrawled across the heavens. Today, we know better, or so we tell ourselves. We measure orbits, analyze spectra, map trajectories, yet still, when Atlas arrives, we cannot resist the instinct to interpret. Some see reassurance, proof of cosmic abundance, a gift of alien chemistry. Others see dread, camouflage, watchers, seeds of invasion. Perhaps this is the true riddle of Atlas, not what it is, but what it does to us. A comet from another star forces us to weave narratives. It exposes our dual nature, curiosity paired with fear, wonder braided with suspicion. Science gives us data, but the human heart craves story. But what if Atlas is not merely story? What if it is in some way a warning? Not intentional, at least not necessarily, but a warning nonetheless. Its chemistry whispers of worlds unlike ours, where planetary formation followed rules all alien to our own. Its speed and endurance remind us how fragile we are compared to the permanence of cosmic debris. Its silence, so complete, underscores how empty the galaxy seems, or how cautious intelligence must be. Warnings do not always come as messages. Sometimes they come as reminders, the reminder that civilizations, if they exist, may not last forever. The reminder that our planet is but one among billions, vulnerable, finite. The reminder that time is vast and merciless, and that survival requires wisdom, not just power. Atlas, then, may be both story and warning, a story we tell to inspire ourselves, to dream of what lies beyond, and a warning, subtle but unyielding, that the universe is not obliged to nurture us, that our survival depends on choices we make here and now. If it is only a comet, then it is a natural wonder, a frozen shard of another world that crossed the abyss to visit ours. If it is more, if some deeper meaning lingers in its chemistry, its timing, its silence, then perhaps it is the cosmos whispering not comfort, but caution. In either case, Atlas is a riddle we may never solve fully. And perhaps that is the point. Some riddles exist not to be answered, but to sharpen the mind, to stretch imagination, to remind us that mystery itself is a gift. And so, 3I Atlas will come and go. In a few short months, its path through our solar system will be complete. It will swing around the sun, accelerate outward, and vanish once more into the abyss between the stars. For Earth, it is a fleeting encounter. For Atlas, it is only another chapter in a journey billions of years long. We will be left with data, spectra archived, orbital tracks plotted, photographs stored in digital vaults. Papers will be written, models refined, conferences held. Scientists will argue over ratios of carbon dioxide, over nucleus size, over formation scenarios. The excitement will fade into routine, and the news cycle will move on. That is the rhythm of science, but something deeper will remain. For a brief moment, the world looked up together. Across continents and cultures, people turned telescopes skyward, shared images online, whispered to their children. That light, it came from another star, and in that act, Atlas became more than comet, more than chemistry. It became a reminder that we are part of a larger story, that the universe does not revolve around us, but still offers us gifts, fragments of other worlds carried across unimaginable distances, arriving unannounced. A reminder that wonder is not extinct in an age of algorithms and screens. It still lives, waiting for us in the night sky. Atlas also reminds us of responsibility. If interstellar visitors are rare, then each one is precious. They carry histories older than Earth, knowledge no laboratory can replicate. To study them is to reach beyond ourselves, to glimpse the galaxy's memory, but to ignore their lessons, to see only spectacle, to dismiss the questions they raise, would be a loss greater than any missed discovery. Perhaps the greatest gift Atlas leaves behind is not answers, but perspective. It forces us to see our own civilization against the backdrop of cosmic time, fragile, brief, uncertain, yet capable of wonder, capable of science, capable of asking questions whose answers may lie beyond our reach, but whose pursuit defines us nonetheless. As Atlas recedes into the dark, we will not follow, we cannot. But its passing shows us what awaits, countless more wanderers, countless more mysteries. Some will be strange, some ordinary, some perhaps extraordinary. Each will remind us that the universe is not silent. It speaks in riddles, in chemistry, in motion. We only need the courage to listen. And so the story ends where it began, with a faint point of light moving against the stars. A visitor, a riddle, a mirror. Whether comet, craft, or ghost, 3I Atlas has done what the greatest mysteries always do. It has made us look up, and to look up is, in itself, an act of hope.